Okay, section 7.3 is about trig substitutions. And so we have a square root thing here, which it's a subtract. And so we're going to make our triangle. And the subtract, we usually put that part over here, square root of 5 minus y squared, which means we'd have to have the square root of 5 on the hypotenuse. And y here, so that c squared minus a squared square root would be that. So, after we make the triangle, we then find the simplest expression we can for y, which would be adjacent over hypotenuse, which is cosine. Cosine of the angle would be adjacent y over the hypotenuse, which I'm putting over here. I'm going to take the derivative, and I get square root of 5. Derivative of cosine is negative sine theta d theta will equal dy. So that's what I'm going to replace dy with. The y squared will be replaced with that squared. And that square root, if I use the simplest, which would be this way, opposite over hypotenuse, so the sine of theta would be the square root of 5 minus y squared over the square root of 5, which I'm going to put over here instead of down there underneath. Multiply both sides by square root of 5, in other words. So now if I make all the substitutions for this, it becomes the integral dy is negative square root of 5 sine theta d theta. The y squared becomes square root of 5 cosine theta squared. And the square root of this is square root of 5 sine theta. Sine thetas cancel, that square root of 5's cancel, and I've got a minus that'll come out, and a square root of 5 that's squared, so that's a 5 in the denominator, so I got minus 1/5 the integral of 1 over cosine squared theta d theta. And so that's minus 1/5. The 1 over cosine squared is secant squared theta d theta. Antiderivative of that is tangent theta. And tangent theta, according to my triangle, would be opposite over adjacent. So this is minus 1 over the square root of 5 opposite. 5 minus the square root minus y squared, square root of that, over the adjacent y. Even though we don't have a square root, we're still going to make the triangle on this one, because substitution would, for the x squared plus 1, will leave a 2x, and no x's to cancel it, so it'd make it hard to do. And this is added, so I'm going to put the square root of x squared plus 1. If I put x here and 1 here, 1 squared plus x squared square root would be the hypotenuse. So the simplest name for x would be opposite over adjacent is the tangent of theta is x over 1. I put the 1 there, but I only need a 1. The derivative then would be secant squared theta d theta equals dx. And this x squared plus 1, well, the square root thing would be, simplest would be put that over 1. And so 1 adjacent over hypotenuse is cosine, so this over 1 is the secant of theta is the square root of x squared plus 1 over 1. So I have all the pieces, so I can now change this integral, and I am doing a substitution. If x is 1, tangent of pi over 4 is 1. If x is 0, tangent of 0 is 0. So there's a change in limits, but we don't have to. We can go back to the x's and then just use that. But I changed my limits, and this would become dx is secant squared theta d theta, and 1 plus 1 x squared plus 1, well, that's secant squared would be x squared plus 1, and then I have to cube that, so this would be secant to the 6th of theta. Square it and then cube it to make it to the 3rd power. All right, so 2 of these will cancel 2 and leave secant to the 4th. So I've got the integral from 0 to pi over 4, and secant, 1 over secant is cosine. So this is the cosine to the 4th x dx. Now the tables tell us that if I want to reduce the cosine, there's a cosine reduction formula. Let me fix this here. Fold this under. There's the cosine reduction formula for, so n would be 4, and this would change into cosine to the 3rd x sine x over 4 plus 3 over 4 integral of cosine squared x. And cosine squared is equal to that one. So this would become cosine to the 3rd x sine x over 4 plus 3/4 times, I'll use the second one because I don't want to deal with 2x when my angle, well, and this is not x, this is thetas. According to the formulas, they're thetas, and so theta, theta, and this would be 3/4 cosine squared theta would be theta over 2 plus 1/2 sine theta cosine theta, and it's not plus c because we're evaluating this all from 0 to pi over 4. So we get, see, cosine of theta is, cosine of pi over 4 is square root of 2 over 2. We're going to get that to the 3rd. Sine of pi over 4 is square root of 2 over 2. That's over 4 plus 3/4. Pi over 4 divided by 2 is pi over 8. And then we have plus 1/2 sine of pi over 4, which is square root of 2 over 2. Cosine of that is square root of 2 over 2. There's the first half, putting the pi over 4 in, minus, if we put in 0, sine of 0 is 0, so that's gone. Put in 0 for theta here, and I get 0. And put 0 for the sine theta here, and all this is 0, so minus 0. So square root of 2 times square root of 2 times square root of 2 times square root of 2 is 4 over 8 times 2 is 16. So 4 over 16 is 1/4. Divided by 4 is 1/16. And this would be plus 3 pi over 32. And then square root of 2 times square root of 2 is 2. We cancel one of the two, so I get 1/4 times 3/4 is 3/16. So 4/16 or 1/4. So I got 1/4 plus 3 pi over 32. Okay, 39. So now we're into the complete the square stuff. So first of all, I got to realize that this is going to be this the integral of dx over, see, half of 4 is 2, so it's going to be x plus 2 squared. But that will create an x squared plus 4x plus 4, and to make 13, I only need plus 9. And so these are added. So I'm going to make my trig triangle with, since they're added, I'm going to put this on the hypotenuse, square root of x plus 2 squared plus 9. Put the messiest on the opposite, that'll be x plus 2, and because square root of that, and the square root of that would be 3. My simplest value for x would be x plus 2 over 3 would equal the tangent of the angle. So if I multiply by the over 3 over here, then take the derivative, I get dx equals 3 secant squared theta d theta, derivative tangent. And this messy square root thing, going with the 3, that would be secant of theta is hypotenuse over adjacent, so that's the square root stuff, over 3, so put the 3 there. So now this integral becomes, the dx is 3 secant squared theta d theta. The square root thing becomes 3 secant theta. The 3's cancel, one of the secants cancel, and I have the integral of secant theta d theta, which is ln of secant theta plus tangent theta from the tables, which becomes ln secant is this over that, or the original one, x squared plus 4x plus 13 over 3 plus tangent, which is x plus 2 over 3. And finally, this one. And they even tell you, suggest, start with integration by parts. Because we got an ln in here, we don't like that. So that's what we usually let u equal when we have an ln. ln of x squared plus 1. So du would be, derivative of ln is 1 over whatever the ln is of, times the derivative of the inside, which is times 2x dx. dv would be the x squared dx. Integrating, that would be, v would be x to the third over 3. So this becomes uv, so that's 1/3 x to the third ln of x squared plus 1. I really don't need absolute value because x squared is 0 or more, plus 1, that's always positive. So don't really need absolute value on that. I can just make them parentheses. Minus uv minus the integral of v, 1/3 x to the third times this, which is 2x over x squared plus 1 dx. So I have 1/3 x to the third ln of x squared plus 1 minus 2/3 the integral of x to the fourth over x squared plus 1 dx. Well, we might be able to do u substitution in this, but then that would leave an x to the third, which is going to get messy. So this is where a trig substitution might be good. And since it's x squared plus 1, I'll put the square root of x squared plus 1. They're added, so I put that on the hypotenuse. It is a square root, even though that isn't. Because, and if I put x here and 1 here, the square root of x squared plus 1 squared is the hypotenuse. So therefore, the simplest expression for x is tangent of theta is x over 1. Derivative, secant squared theta d theta equals dx. Expression for the x squared would be, using the 1, it would be secant theta equals hypotenuse over adjacent over 1. So we have 1/3 x squared ln of x squared plus 1 minus 2/3 the integral. X to the fourth will be tangent to the fourth of theta. Dx will be secant squared theta d theta. And this will be secant squared theta, because that squared would be that. Secant squareds cancel. And so we get 1/3 x squared ln x squared plus 1 minus 2/3 the integral of tangent to the fourth. Well, tangent to the fourth. I'm going to fold this again. There's a reduction formula for tangent to the fourth. M would be 4, and so this would be tangent to the third, x over 3 minus the integral of tangent squared x. Oh, these are thetas. D theta. And the integral of tangent squared, we can just use the reduction formula again, I guess. So we're going to get 1/3 x squared ln x squared plus 1 minus 2/3. I'll just leave this tangent third theta over 3 minus, now parentheses for this is going to be, with M2, this will be tangent of 2 minus 1 is 1, x over 1. minus the integral of tangent to the 0, which is just 1 dx, or d thetas, these are. So the integral of d theta is just theta, and this is tangent theta. So we have 1/3 x squared ln x squared plus 1 minus 2/9 tangent to the third theta. And then we'd have plus 2/3 tangent theta plus, nope, minus, change that to plus, and then that to minus. So minus 2/3 integral of theta is just theta. And so we got x's and thetas, so we got to get the thetas out of there. So we have 1/3 x squared ln x squared plus 1 minus 2/9. The tangent is just x. X to the third, see, tangent is x, plus 2/3 x, and then theta is minus 2/3 tangent inverse of x. Oop. There we have our final answer, as far as I want to go. Okay.